Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 175. Page 175, and today is our lesson number 179. Problem number 162 is what we're going to do. Problem 162 is something that we already did together yesterday on day number 177. Yesterday when we solved this problem, and if you have not watched day 177, make sure you go and watch that video first. In that video, yesterday, we solved this problem in a non-classical manner, in a non-classical method, without the algebra. Today, we're going to do it the proper way, the algebraic way. Now, like I explained yesterday, the method that we're going to do today is not something that you want to contemplate doing on the real exam. It will be a sheer waste of time. It will take too long. Your job in the real exam is to get the right answer in the most efficient manner possible, which was the method that we did yesterday. Today, what we're doing here is just for learning purposes, just to get some practice on the algebra and nothing more than that. It is not something you would do in the real exam. Now, having said that, it does involve algebra because it's the classical method. It is about as classical and traditional and academic as you can get, and therefore it is not meant for everybody. It is only for those people who can brook it. Only for those people who can tolerate it, who can handle it, who can stomach it, who can brook it. In the event that you are not familiar with this particular word, and if you would like to learn this particular word and some other interesting word to help you improve your vocabulary, to expand your vocabulary, just like the video that you are watching right now to help you with the math portion of the exam, to get a decent score in the English portion of the exam, having a decent vocabulary is the must. Having a decent vocabulary is a must. For that very reason, I have put together some vocabulary videos which you will find at my channel. Just look for vocabulary videos and you will find them. Day number 4 is when we learn this word brook. So here's what's going on. We're doing this problem in a classical manner. Let's pretend that the total distance that this lady is going to travel is d miles, the d for the distance. We are told that she travels a certain percentage of her journey, which they're calling x%, at 40 miles an hour. Well, if she's going to travel x% at 40 miles an hour, which means the remainder of the journey, which is going to be whatever is left over from 100 minus x% must have been at 60 miles per hour. If you're going x% at 40 miles per hour, x% means x over 100 times d, which is the total amount of distance. This is the distance she's going at 40 miles per hour. Similarly here, 100 minus x% means over 100 times d at 60 miles per hour. Now, like I already said, it is not meant for everybody. So if the algebra gives you too much trouble, don't worry about it. Just do the non-classical method. But I'm not going to stop here and explain every little excruciating detail, because otherwise it will get to be too much. Okay, so here's what's going on here. So therefore, the amount of time that it will take for the first leg of the journey, the first half of the journey, is simply going to be this distance, x times d, over 100 times the amount of distance that we times the speed, which is 40 miles per hour. And this is the amount of miles. As you can see, the miles are going to cancel out and the hour is going to end up on the top. That's the first hour. The amount of time that it takes for the first half of the journey. Similarly, the amount of time that will take for the second half of the journey is going to be 100 minus x times d over 100 over 60. Again, 60 miles per hour. And on the top we have miles. The miles drop out, the hour ends up on the top, and then we get the time. Therefore, her average speed over the entire period is simply going to be the total amount of distance that she traveled divided by the total amount of time, which is this and that. Therefore, her average speed over the entire journey is going to be the total distance, which is d miles, which is the total distance from the top right here, over the total time, which is this guy and this guy. X times d over 100 times 40 plus x 100 minus x times d over 100 times 60. That's it, we are done. All we have to do now is to manipulate this expression until it looks like one of the answer choices. But the hard part is done. So we're going to work on this one on the top. Let's find the common denominator here. The common denominator is going to be 100 times 40 times 60. So our average speed is going to be 100 times 40 times 60 times the d, because this denominator is going to end up on the top, and over here we'll have x times d times 60. And over here we will have 100 minus x times d times 40. I see a d here, I see a d here, I see a d here. Let's take out the d common. So if we take out the d common on the top, we'll end up with 100 times 40 times 60 over d times 60x plus 100 minus x. d is taken out common times 40. As you can tell, I warned you from the very beginning, this is only if you can broke it. And this is certainly not something that you ever want to contemplate doing it on the exam. This is not how you take the real exam. This is just purely out of curiosity that we are doing here. The quicker way is what we did yesterday. Cancel out the d from the top and the bottom by dividing the top and bottom by d. And over here, on the bottom, we're going to end up with 60x times 100 times 40 times 40 times x. Let's do it. Let's continue on the bottom here. So on the top is simply 100 times 40 times 60 over 60x plus 100 times 40 minus a 40x. A 60x and minus a 40x will simply be 20x. So that's what we're going to rotate here. 60x and a negative 40x is simply 20x. Let's take out the 20 common. Let's take out the 20 common from the top and the bottom. If you take out the 20 common, here it will become 100 times 2 times 60. Now, on the top, you can take it out. We could have taken out 20 from any one of them. Had we taken out 20 from 100, it would have become 5, and these two would have stayed the same. Had we taken out 20 from here, this is exactly what we did, became 2. Or we could have taken out 20 from the 60, and it would have become 3. It's the same thing. This is what I mean. If I have to explain these things, then don't worry about it. It's not meant for you then. I don't mean that in a condescending manner. You have to be realistic. You have to be pragmatic in the exam. Do you understand? You have to know your limitations. Your job is to maximize the amount of knowledge that you have. Maximize the return on it. Get the most out of it. So you must learn how to apply your knowledge, whatever knowledge that you have, in mathematical knowledge and mathematical efficiency and what's the word I'm looking for? However conversant you are with the algebra, apply it in the most efficient manner. Do you understand? So take out the 20 and you will end up with the x here. And here if you take out the 20, it's 100 times 2. 100 times 2. And the 20 cancels out. And we end up with, on the top, we end up with 12 times 2 times 6 is 12. And then we have 1 0, 2 0 and 3 zeros. Over 100 plus x plus 200. Voila. That is our answer. It was quite a nasty journey. It is quite a nasty journey, something that I would never attempt it myself, something that I will never attempt myself, not because I can't do it, but because there is a very good chance that I'm going to end up making some mistake, some careless mistake because of the time pressure. So avoid it. There are too many pitfalls in it. That was it. Another thing that I want to point out to you before I forget it, I almost forgot about it, I was about to close the video. Another thing that I want you to point out to you is this part right here. Please pay attention. You see, because of the fact that at the very end, when we do all the manipulation, the d, the amount of total distance, drops out from the picture. You see, it drops out. Because the d drops out in the solution of the problem, that tells us that the amount of distance that you're going to travel plays absolutely no role in it whatsoever. It plays absolutely no role on it because it drops out, which is what allows us, which is what gives us the luxury of pretending the distance to be anything that we want. You can pretend, you can make up any number that you want for distance, and had we simply made up a number for amount of distance instead of doing it the algebraic way, this is pure algebraic way here, so had we made up a concrete number, the solution would have been much easier, which is precisely what they do in the book. If you look at the book here, I'm going to give you the page number. In the book, if you were to turn to page number 240, they plug in 100 for D. They pretend that the total distance this person is traveling is 100 miles, which makes the calculation much easier. I didn't do it that way because I wanted to give you the flavor of what it is in the purest sense of the algebra. In the book, the solution that they give you is algebraic, but it's not algebraic solution in the purest sense of the word because they made up a number for one of the variables. This is the pure algebra, and I wanted to show it to you what allows us to make up a number, any number that you want for distance, and of course a smart number to make up for a distance would be 100 because we are dealing with percentages. But this is what allows it. D drops out. I'll see you tomorrow, okay? Bye now.